Okay, guys, so today we are going to talk about the coordinate transformation of vectors, coordinate transformation of vectors in 3D space. And in this video, we are going to take the more analytical approach. Okay, so analytical approach. So, a vector v in an original unrotated coordinate system xyz is given by vx ex plus vy ey plus vz ez, where xyz is the original coordinate system and ex ey ez are the unit vectors along xyz direction. When the coordinate system is rotated through an arbitrary rotation into x prime, y prime, z prime, the same vector v has a different set of components along the rotated coordinate directions given by vx prime, ex prime plus vy prime, ey prime, vz prime, ez prime, where Vx prime, Vy prime, Vz prime are the components along the x prime, y prime, z prime directions. So x prime, y prime, z prime is the rotated coordinate system. Okay, and by coordinate transformation, we mean we want to find a relation for Vx prime, Vy prime, Vz prime in terms of Vx, Vy, Vz and the rotation of the coordinate system. So Vx prime being the component of v along the x prime direction. So any vector, its component along a certain direction is given by the dot product of the vector with the unit vector along that direction. So therefore vx prime being the component of v along x prime direction is given by the dot product of v with the unit vector along x prime direction, that is ex prime, and then this ex prime is outside. Similarly, vy prime is dot product of v with ey prime, then this ey prime, plus vz prime is again the dot product of v with ez prime, and then this ez prime. And v is given by again this vx cx vy ey plus vz ez, right? So if we write it down there, so this becomes vx ex plus vy ey plus vz ez dotted with ex prime. The whole thing outside this ex prime remains, plus again v vx ex plus vy ey plus vz ez, the whole thing dotted with ey prime and then ey prime, plus again vx ex plus vy ey plus vz ez, the whole thing dotted with ez prime and this outside ez prime. Okay, now we do the dot products. Vx, Vy, Vz are just numbers, right? So they come out and we actually essentially do the dot product between the vectors Ex and Ex prime. So this becomes Vx dotted then Ex dot Ex prime. Okay. plus similarly Vy Ey dot Ex prime plus Vz, then Ez dot Ex prime, and the whole thing Ex prime is outside, plus again Vx, we dot Ex with Ey prime plus Vy Ey with Ey prime plus Vz Ez with Ey prime, and this Ey prime is outside, plus again the last one Vx Ex dotted with Ez. Here it's Ez prime, guys, I made a mistake here. See, Ez prime, so dotted with Ez prime plus Vy Ey dotted with Ez prime plus Vz Ez dotted with Ez prime, and Ez prime is outside. And actually we are essentially done with our uh, uh, transformation. If you can realize, this is nothing but the component of V in the x prime direction, this is nothing but the component of V in y prime direction, and this whole thing is nothing but the component of V in z prime direction, right? Because now, because V is, so let's, because V is given by Vx prime Ex prime plus Vy prime Ey prime plus Vz prime Ez prime in the rotated coordinate system x prime y prime z prime. We can compare this with our this result, and then Vx prime is nothing but Vx prime is nothing but this, the whole thing inside this bracket here, right? So this is Vx times Ex dot Ex prime plus Vy Ey dot Ex prime plus Vz Ez dot Ex prime, and similarly Vy prime is given by Vx Ex dot Ey prime plus Vy Ey dot Ey prime plus Vz Ez dot Ey prime, and Vz prime similarly is given by Vx Ex dot Ez prime plus Vy Ey dot Ez prime plus Vz Ez dot Ez prime, and the dot product between two vectors is the product of their magnitudes times the cosine of the angle in between them. So the dot product of two unit vectors is just 1 times 1 times the cosine of the angle in between them, right? So we can also write this as Vx prime equal to Vx times cosine of the angle between x and x prime. So I'll write it in this way. Okay, cosine of the angle between x and x prime, Vy times cosine of the angle between y and x prime plus Vz cosine of the angle between z and x prime, Vy prime equal to Vx cosine of the angle between x and y prime plus Vy cosine of the angle between y and y prime plus Vz cosine of the angle between z and y prime, and Vz prime is equal to Vx cosine of the angle between x and z prime plus Vy cosine of the angle between y and z prime plus Vz cosine of the angle between z and z prime. And just like last video, we can write it in a matrix form where Vx prime, Vy prime, Vz prime, the components in the rotated system x prime, y prime, z prime is given by this. Just writing this above equation in matrix form, guys. Cos z and angle between, so cosine of angle between x and y prime, cosine of angle between y and y prime, cosine of angle between z and y prime, cosine of angle between x and z prime, cosine of angle between y and z prime, cosine of angle between z and z prime. Okay, times the original components in the xyz direction, vx, vy, vz, and this is the transformation matrix, also called the direction cosine matrix. Cosine matrix, and also is the transformation matrix. And that's how you do coordinate transformation of vectors. And this is the analytic approach which you can use for any arbitrary rotation in 3D space, even higher dimensional space. Thank you.